Howdy, howdy. Back with part 2. I hope that our batteries will cooperate tonight. Victoria, I'm going to take you up on that training me on the phone. I'm going to buy a tripod first, so once I get that, I'd appreciate you tutoring me. Alright, number 10 is the Trig ID. I think that I just covered in the last video. We're going to actually bleed this one a little and get another Trig ID out of it. What I'm going to do is I'm going to take all the terms in Trig ID number 10, sine squared plus cosine squared equals 1, which I think is just an amazing fact in itself. But anyway, I'm going to take each term in this equation and divide it by the same thing, and the thing I'm going to pick, the thing, is sine squared. So why in the world, here I found a little paperweight here, it's the world, why in the world did I choose to divide sine squared and cosine squared and 1 by sine squared? Because I'm searching for another useful trig identity, and this creates a 1, which is always attractive. So number 11, this becomes 1, and then I have here cosine squared over sine squared, and just cosine over sine is a trig ID from our other paper. Let's see if I can find it. Hang on to your seats. Sine squared over cosine squared. There it is. Number 7 is tangent. So sine over cosine is tangent, and cosine, so like the one we have, but not exactly, cosine over sine is cotangent. So therefore, back in the screen again, cosine squared over sine squared is cotangent squared theta equals, and what's 1 over sine? It's the it's the reciprocal of sine, 1 over sine, and that is the cosecant, CSC, and it's squared in this case. So this is our next trig ID. 1 plus cotangent squared equals cosecant squared. So that's number 11. All right. Number 12, I'm going to also bleed out of, I'm going to start, this is not the ID, but it's what I'm going to bleed to get the new ID. So I'm going to take this one, and instead of dividing by sine squared on each term, I'm going to divide by cosine squared. Why in the world am I dividing by cosine squared on each term? What is the method in this madness? Just like before, it'll create a 1 there, so let's see what shakes out. Sine over cosine, we just mentioned, is tangent. So, oops, is tangent squared plus 1 equals 1 over cosine and squared, but 1 over cosine, that's the reciprocal of cosine, which is the secant, and it's squared. So that is number 12. Tangent squared plus 1 equals secant squared. Alright, let's see what other trig IDs are floating around. Alright, the other ones that I want to mention are the ones that are called cofunctions. So cofunctions are like this. Let's go back to our triangle so I can get this out of you. A, B, and C. So I was wondering, what is sine? If this is theta, what is sine of theta? So sine of theta is opposite over hypotenuse. I was kind of bummed that you didn't like your trig assignment today. You found it boring and tedious, and I thought it'd be something you would like because they're kind of doable. Most people get them right without too much fuss. But anyway, it is what it is. Sine of theta is b over c. Now, I was wondering if I look at this angle. First of all, what is this angle? Well, if this is theta and this is 90, it has to add to theta and 90 to get 180. So I know that its name is 90 minus theta, because theta plus 90 minus theta plus 90 does come up to 180. Alright, so let's see if we can mess with that. So I was wondering, and I'm sure you were as well, what is the cosine of 90 minus theta? So that's the other angle up here. So from this position, this angle, we're looking for adjacent over hypotenuse. The side adjacent to that is here, b, and hypotenuse here equals b over c. Oh my, look at that. This equals b over c and this equals b over c. So whenever two things equal the same thing, they're equal to each other. So that's trig ID number 13. Sine of theta equals cosine of the other angle, 90 minus theta. And that will also work this way. The cosine of theta equals sine of 90 minus theta. So I won't prove that one, but it will work the same. All right, let's do, so because of this relationship, we call these things, they're cooperating with one another in this way. Sine of the one angle, not the right angle, but one angle is cosine of the other angle. Cosine of an angle equals the sine of the other angle. And this cooperation makes them co-functions. And that's why we call it sine and cosine. All right, so now we go over to we'll develop 15. And let's see if we can get this triangle back in view. This time, let's look at, let's see, sine and cosine. Let's do tan. Tan theta. So tangent in this triangle is opposite over adjacent, b over a. And I was wondering, and now I know you are as well, what is cotangent of the other angle? So from this position, we want cotangent, which is adjacent over opposite. So it's b over a. Voila. Okay, so this leads us to the fact, number 15, tangent of theta equals cotangent of the other angle. And cotangent of theta equals tangent of the other angle. It works the same. And again, I'll just number that, but I won't show it to you. So once again, these are cooperating, and that's why we call it tangent and cotangent. Sine and cosine. These are called the co-functions. All right, 17 is going to be secant of theta. So going back here, secant is hypotenuse over adjacent, c over a. And I was wondering what cosecant of the other angle is. So cosecant is, from this side, is hypotenuse over opposite, c over a. Yalla. 17 is secant of theta equals cosecant of the other angle. All right, and 18 is going to be the other side, the other version. Cosecant of an angle is secant of the other angle. All right, that's the end of our trig ID list. That's a lot. We went over 18 of those. And I think that's going to end our video for this weekend. I hope it's a good one for you, and we'll have some housekeeping chores to do on Monday with our comp books and looking for our quiz, toward our quiz on Tuesday. But then we'll pull out about 15 problems, 12 or 15 problems using these Trig IDs. Beautiful they are. All right, that's it. I'll talk to you on Monday. Have a great weekend, and goodbye.